We observe an infinite length ladder consists of resistors here. Our goal is to determine the equivalent resistance for X as seen from the two input terminals shown here. As you can see, this network consists of a single cell repeated a large or infinite number of times. To solve this type of ladder network, the best approach is to separate one cell from the network. Here we isolate one cell. Now, if you look at the right hand side, we see the same network as before, because removing this one cell has practically no effect on the network since the number of repetitions is infinite. So the input resistance after removing one cell still remains X. So by substituting, we can replace the entire network on the right hand with a single resistor X and connect it to our cell. Now the input resistance must again be equal to X. Now X is in parallel with R. We replace this with an equivalent resistance. Now we can write that X equals R plus R in parallel with X. Now we carry out our simplification until we arrive at a quadratic equation. This quadratic equation has two roots. Since R is positive and X, the equivalent resistance must also be positive. We choose the positive root, which gives us X equal to be approximately 1.618 times R. Other similar ladder networks can be solved using the same method.